Good morning everyone. This is the last session of chapter number 1, real numbers. In our previous class, that is in part 6, we discussed a little about decimal representation of numbers. Today let's discuss the decimal forms of rational numbers. In fact, the first two forms, that is terminating decimals, non-terminating recurring decimals, are rational numbers. Let's see these things in detail. Let us study the following terminating decimals. A 0.35 is equal to 35 by 100, and if we factorize the denominator, then we are getting the answer as 2 square multiplied by 5 square. Now if we change this to the lowest form, then we have got the answer as 7 by 20, 35 by 100. Okay, so if we divide 35 by 5, then we are getting 7, and 100 by 5, then we are getting 20. Now if we change the prime factorization of 20, then we are getting the answer as 2 square multiplied by 5. V, this is the second terminating decimal, 0.124. The p by q form or the fraction form is 124 divided by 1000. Again, if I write the denominator in the prime factorization, then I have got the answer as 2q multiplied by 5q. If we change this in the lowest form, then the answer is 31 by 250. So if we further factorize the denominator, then we have got the answer as 2 multiplied by 5q. Similarly, for C also, we can see in the same way. Here, one thing we observe is that the prime factorization of denominators for the lowest form of each of the above decimal is of the form 2 to the power n multiplied by 5 to the power m, where n and the m are non-negative integers here. So students, from the above examples, we can say that a rational number p by q which is in the lowest form will have terminating decimal if its denominator has the form 2 to the power n multiplied by 5 to the power m, where n and m are non-negative integers, that is 0, 1, 2, 3, etc. You can see this with this another example also 1 by 2. 1 by 2 can be written as 1 divided by 2 to the power 1 multiplied by 5 to the power 0. Here again, this is in the form of 2 to the power n multiplied by 5 to the power m, and the decimal form of this number is 0.5. Again, you see another example 1 by 25. Here again, the denominator will be in the form of 2 to the power 0 multiplied by 5 square, and the decimal form is also 0.04. So clearly we observe that for every that is terminating decimal, the rational number will have the denominator in the form of 2 to the power n multiplied by 5 to the power m. Next, let us go for non-terminating recurring decimal. So for example, 0.333. 3 repeats continuously. In class 9, we calculated the p by q form of this as 1 by 3. Here the denominator is not in the form of 2 to the power n multiplied by 5 to the power m. Again, if we take another example, 0.4545, 45 repeats continuously, then the p by q form of this will be 45 by 99. After cancelling by the common factor 9, we observe that the lowest term is 5 by 11. Here the denominator is not in the form of 2 to the power n multiplied by 5 to the power n. Again, let us discuss one more important condition. If I write the rational number 3 by 6, the prime factorization of denominator is 2 to the power 1 multiplied by 3 to the power 1. Here we see that the prime factorization of the denominator is not in the form of 2 to the power n multiplied by 5 to the power m. Still, the decimal form of this rational number is terminating. It means that it contradicts with the condition what we have got for a terminating decimal. Why is it so? It is so because before changing 3 by 6 to the lowest form, we are writing the answer. That's why we have got a contradictory answer. So dear students, you change the given number to the lowest form first and check for the terminating decimal or not. From the above discussion, we can conclude that rational number p by q will have terminating decimal if the denominator, which denominator? The denominator which we have taken from the lowest form of the rational number. If it is of the form 2 to the power n multiplied by 5 to the power m, then you will get terminating decimal. Then secondly, it will be non-terminating recurring if the denominator, which is taken from the lowest form of the rational number, have other prime factors besides 2 and 5. So you take care of this condition whenever you observe any other prime factor besides 2 and 5, then you can say that the decimal representation of that rational number will be non-terminating recurrings. So these are today's lesson. So next you do the following problems 1, 2, 3, 4 as homework exercise. First question is from your exercise 1.4. Question number 2 and 3 are multiple choice questions, and for question number 4 you have to write 2 rational and 2 irrational numbers lying between cube root of 4 and the cube root of 5. Okay, thank you all. Let's meet again in chapter number 2. Have a nice day at home.